Okay, so number 4 says write the equation of a parabola with a vertex of 0, -3 and a focus point of 6, -3. So the first thing I'm going to do is start off by drawing some axes. Just kind of looking at this, I go 0, -3, 6, -3. It kind of tells me, you can kind of picture in your head that's going to be in the third quadrant. So that's why I'm going to draw my picture primarily in the third quadrant here. Tells us our vertex is 0, -3, so I'm going to go 1, 2, 3, put my vertex point. The other thing I'm going to do is plot my focus point, so that's 1, 2, 3, 4, 5, 6, down -3. Then we know that the focus point has to lie within side of the parabola that we sketch. So we know our parabola has to be facing this way. And we know if it's a sideways parabola, we have an equation that looks like this: y minus k, all being squared, equals 4p. Whoops. So as I was saying, 4p, x minus h. So we just basically need to fill in the blanks. So my parabola has a vertex of 0, -3. So the y value there is -3, so this is going to be plus 3 here. The p value, that's the distance away from the vertex, between the vertex and the focus. If you count from the vertex to the focus, that's 6 points. So there's going to be a 6 in here for p. Then the vertex, again, the x value is 0, so we're just going to put -0 in here. So now we filled in our blanks and we pretty much have our equation. Sometimes they might simplify it a little bit further, but you want to start out with at least this and then take a look at your multiple choice. But understand they might write y plus 3 squared equals 4 times 6 is 24 x, because x minus 0 is just simply x. So either one of these they might write. If it's free response, do what you think's right. Either one I would accept. Okay. Number 5 involves graphing a hyperbola. So this is a little bit more difficult than the last problem, but hopefully it's fresh in our heads because we just had this unit. Only problem with graphing this is that we have to first write in standard form before we can determine some of the things that we need for graphing it. So first thing I'm going to do is say, okay, well, this is definitely a hyperbola because it's got two things being squared. It's got the y being squared, it's also got the x being squared. So I know it's going to be a hyperbola because we've talked about parabolas and hyperbolas, and parabolas only have one thing being squared. I'm going to start off by writing I'm going to start off by writing 4y squared minus the 16y minus the 9x squared, so I'm just copying down the equation so I have some room to do some work over here, plus 18x plus 43 is equal to 0. Well, first thing I'm going to do, I know in a hyperbola that only the x's and y's should be on the left-hand side, so I'm going to get rid of that 43. I'm going to do two steps. I'm going to put the 43 on the other side. I'm also going to go ahead and factor out the coefficient for each squared term, the y squared here and the x squared here, because that's what we're going to need to do in order to do this problem, is complete the square. So I'm just kind of leading up to that. So just kind of bear with me. I'm going to write 4, factor out the 4, that means there's y squared left inside, minus 4y, plus our blank, that's going to be the completing the square part, minus 4 times whatever we add on the inside to keep everything balanced. Now this is really important here. I'm going to write minus 9 x squared. Now if I factor out that 9 on the outside, we have to make sure that whatever we put on the inside here will redistribute to give us what we have here. So what times negative 9 would give us positive 18x? Well, that's just simply minus 2x. So be careful. Basically, the sign changes in these two steps. Be careful. Plus the blank spot for completing the square, minus whatever we put on the inside, equals negative 43. I just put the 43 on the other side. Now, a little key thing here is that this is going to eventually be distributed to here. So really what we're doing is multiplying this by negative 9. So we have to add 9 times this number to keep everything balanced. Because again, if we subtract something on the inside, which is basically what's going to be done here, because we're multiplying by the negative, we have to add it on the outside because that keeps, again, everything balanced. So now I'm going to go ahead and fill in my blanks for completing the square. I take half of the middle number, so half of negative 4 is negative 2, then I square it. Negative 2 squared is 4. Half of the middle number again is negative 1. Negative 1 squared is just 1. So now I can write it as a completed square by saying 4y minus 2 squared minus 9 x minus 1 squared, and then our like terms, which is the 4 times 4 is just 16, and the 9. Oh, and I almost forgot that this is a negative 16, so negative 4 times 4 is negative 16, plus the 9 is going to give us a negative 7 after we combine our like terms. So minus 7 equals negative 43. So now, again, I need basically 2 fractions squared minus another fraction squared equals positive 1. So I still have a little bit of work to do there. So I might have misspoke there. What I meant to say was I need a fraction minus another fraction equal to 1. That's the basic idea that I'm trying to get across. So I'm going to write 4y minus 2 squared minus 9 x minus 1 squared. I'm going to put the 7 on the other side here, so in order to get rid of this negative 7 I have to add 7 on the other side. If I add 7 to negative 43, I get negative 36. I'm going to go ahead now and divide everything by negative 36. And remember, when we divide by negative, all the signs will change. So what I have now is negative y minus 2 being squared all over 9. A negative divided by a negative is going to give us a plus or a positive. 9 divided by 36 gives us 1/4, so we know 4 will be on the bottom. Negative 36 divided by negative 36 is 1. So we're just about there. The only thing I'm going to change is I'm going to put it in the right order. It's supposed to be a fraction minus another fraction, so I'm just going to simply write x minus 1 squared over 2 squared, because 2 squared is the same thing as 4, minus y minus 2 squared over 3 squared, because 3 squared is the same thing as 9, equals 1. So remember, we need these values on the bottom to be squared values in order to graph our hyperbola accurately and graph that box that we had done in unit I. So I'm going to make a few notes here. The center is positive 1 and positive 2. That comes from the x and y values, but remember they're the opposite. So I'm going to first plot that point, 1, 2. Now, the x comes first here, so we know that it's going to be opening left and right. That's what our parabola should look like when we're done with it. So our vertices have to be to the left and right of each other. So I'm going to go over a distance of 2, because that's what's down on the bottom here in the denominator. I'm going to go to the left 2. Then, what's in the denominator of the y squared term? That's just 3. So I'm going to go up 3 from each one of these points. And also down 3 from each one of the vertices. So 1, 2, 3 gives us a point right here. And down 3 from the vertex again gives us a point here. So here's my 2 vertices. This point here is my center. I'm going to sketch some diagonal lines in just to help give us a little bit better picture. These are the asymptotes. The question actually asks us to find the equation of the asymptotes, but I'm going to go and cross that off in a minute because that was something we never got a chance to cover, so I'm not going to worry about that now. That wouldn't be fair to put in your final if we didn't cover it. So here, whoops, sorry about that. Let's try that again. So here's our hyperbola. And then it asks us to state a few things. So let's cross off what we've done so far. It's kind of a longer problem. We've identified the center. We said that was 1, 2. We've got the vertices, but we didn't say what they were yet, so the problem does want us to say that. So I'll go down here and write what the vertices are. Vertices, if we just identify, that's 3, 2. And the other one is negative 1, 2. So now we're completely done with the vertices. Asks us for the focus points. So I'm going to use the Pythagorean theorem and say 2 squared plus the 3 squared equals c squared. If we simplify this, probably do this in our head, the first term is going to be 4 plus 9 is going to give us 13. So what does that mean? That means that C is approximately 3.6. So it'll probably help to use that approximation when we're graphing. So I want to go 3.6 from the center. Okay, so a lot of people go from the vertices, but we always go from the center. So our focus points are going to be 1, 2, 3.6. So we just kind of make an approximation. And our other focus point, 1, 2, 3.6. Again, make your best guess. If we identify those points, the first focus point on the left is at negative 2.6 and 2. The other focus point is at negative 4.6 and 2. So like I said earlier, I'm going to cross out the asymptotes part because, again, we sketched them in, but we didn't really talk about finding the equations of the asymptotes, so I'm not going to worry about that. So really all I'm expecting is you graph them in to get a little bit more accurate of a picture. So we did basically 1, 2, 3, 4 pieces. Oh, and I guess we did write it in standard form, so that was probably the hardest part.